Yeah, good morning to all. Today I'm going to teach with water and its treatment. So first we need to discuss about what is the water. So what type of water? So this is the introduction part. Water is what is a natural gift on the earth, and it is an essential component of human beings. Not only human beings, it is also essential for animals, plants, right? So without food we can survive for a number of days, but without water we cannot survive. So this water is used for drinking and cooking, bathing and cleaning and washing also. Water is found in the three states, that is what it is: a liquid state, solid states and vapor states. The freezing point of water is 0 degrees centigrade, and boiling point of water is 100 degrees Celsius. Several special behavior found the water are due to hydrogen bonding present in it. So here in nature the water is present in abundance. About 96% of water forms the ocean, and 2.2% of forms ice and snow is, so 1.2% form the groundwater. Right? So it is therefore essential to use available water carefully and economically. The rest form the surface water and the water present in the atmosphere. The various sources of water are river, tanks, reservoirs, seas, oceans, wells, and next rain and glaciers and etc. So the hard water, so there are two kind of water is there. One is what is a hardness of water and soft water. What is the hardness of water? The water is, so here for example, if you take water sample, when it is mixed with the soap solution, it will give more scum or precipitation, then that comes under hard water. So the same sample of water can be treated with the soap solution, then it will give, so here the less lather, more lather, so that is called as what is a soft water. So here the hard water again can be classified two types based on chlorides and sulfates. For example, if you take the hard water can be classified into two types, that is a temporary hardness as well as the permanent hardness. Right. So here, for example, water is good solvent, and even it is called as what universal solvent. Most of the inorganic solvents are soluble in water. The water that are calcium, magnesium or dissolved it causes hard water. So for example, if you take hard water, there are two types. There is a temporary hardness and permanent hardness. Temporary hardness is due to the presence of, so here the carbonates and carbonates of magnesium, bicarbonates of magnesium, or carbonates of calcium, or bicarbonates of calcium, right? So generally we can discuss like this. So we can define the temporary hardness. Temporary hardness is due to the presence of carbonates and bicarbonates of calcium and magnesium, that is called as what is a temporary hardness. Permanent hardness is, so it is due to the presence of chlorides and sulfates of calcium and magnesium, then that is called as what is a soft water, right? So permanent hardness of water. So the temporary hardness, so we can easily remove by boiling method or heating method, but the permanent hardness cannot be removed by boiling method or, so here the heating method. So we have a special kind of techniques are there to remove the permanent hardness. So there are, for example, lime soda process, zeolite process, ion exchange process, demineralization process, right? So these are all are the special kind of techniques which are. This kind of techniques is comes under external treatment of water. So there are two types of treatment of water is there: internal treatment as well as the external treatment. So if you go for the internal treatment by adding of phosphorus, chlorides and bleaching powder, these are all will comes under internal treatment. External treatment is, there are different kind of techniques are there. So RO treatment, reverse osmosis, and next one is what lime soda process, zeolite process, ion exchange process, demineralization or deionization process. These are all will comes under, so external treatment of water, right? So for example, if you take domestic uses, disadvantage of hard water. So if you use the domestic uses, washing, bathing, cleaning, cooking, drinking, so this hard water is a disadvantage, right? The washing also, when you wash with water, so when this sample of water can be mixed with the soap solution, will give, so here the more precipitation, right? That is what it is. It not at all useful for the, or so here washing purpose, bathing purpose, cooking purpose, and drinking purpose. Drinking purpose, for example, if you take, so here the hard water, it causes bad effect to our health, right? Calcium forms oxalate crystals in urinary tracts, right? So therefore you'll get diseases of water. So here the kidney problems, you'll get these kind of problems if you use the hard water, right? So industrial users, right? Textile industries, sugar industries, dyeing industries, laundry, pharmaceutical industries, and paper industry. So we can use soft water to avoid this. This is the types of hardness. Temporary hardness is a, permanent hardness is a. Just now we discussed temporary hardness is, so here the presence of, so here the carbonates and bicarbonates of calcium, magnesium, and permanent hardness is presence of chlorides and sulfates. We already discussed. Temporary hardness we can easily remove but boiling method or heating method, but permanent hardness we cannot remove by boiling method or heating method, right? Just for we discussed measurement of hardness of water. The hardness of water can be measured in terms of calcium carbonate equivalent, right? So thus calcium carbonate equivalent, how we are going to calculate? Calcium carbonate equivalent is equal to, so given weight into 100 by molecular weight, that we are going to define. So when we are solving the problem, then we need to discuss about this type of things. So units of hardness, there are different types of units of hardness is there. Parts per million, milligram per liter, degree per clerk, and degree per pinch. So there are one relation is there. So here the parts per ppm, milligram per liter, degree clerk, and degree French. What is a relation? 1 ppm is equal to 1 milligram per liter, that equal to, so 0.07 degree clerk, that equal to 0.1 so degree French. That relation is very important while solving the problem. So this is that. See, so now last one you check it. So parts per million, that is what it is. So these are all units of hardness. I have just now discussed one relation. 1 ppm is equal to 1 milligram per liter, that equal to 0.07 degree clerk, that equal to 0.1 degree French. That is, this is very important. Estimation of hardness of water by complexometric method. So this complexometric method we can use of Edta method, right? So this generally you have a discussion about so what we discussed volumetric analysis in 10 plus 2 grade, that is similar to this one. So for example, if you take volumetric analysis, the acid is generally we are going to take 250 ml of conical flask. In the 250 conical flask we need to filtrate out 20 ml of acid is filtered into 250 ml of conical flask, then add any indicator. It may be of methyl orange indicator or phenolphthalein or anything. When you add the indicator, you will get initially one color will get. For example, so given acid we are adding methyl orange indicator, the initial color is pale yellow. So when you are titrating against the base, the pale yellow color is changes to the colorless, right? That you are going to find out in the volumetric analysis. In this EDTA method, so similar method where we are going to use. So here, but instead of using this, for example, if you take hard water, so that means hard water is tap water. So you can take 20 ml of tap water into 250 ml of conical flask, then add EBT indicator. You know what is the full form of EBT? Eriochrome black tea. Eriochrome black tea, and then add 5 ml of buffer solution. Why we are adding the buffer solution? To maintain the pH of the solution, we are going to add the buffer solution, then titrate it against with EDTA solutions. Then this initially when you are adding the EBT indicator, you will get wine red color. Wine red color, then it will be changes to the dark blue color, right? So that is what we are going to find it in the EDTA method. EDTA full form is ethylene diamine tetraacetic acid, right? So now, so these are all the chemical reactions. This is a chemical reaction, ethylene diamine tetraacetate or tetraacetic acid. So the principle is what ADTA is a colorless stable complex with having of calcium and magnesium ions. These calcium and magnesium ions which are present in water sample. So these water sample, when you add with the EBT indicator, it will get, so here the wine red color. So these to maintain the pH of the solution, we are going to add 5 ml of buffer solution. So then, so the pH of the solution, it should be maintained 9 to 10. Then, so the buffer solution, what is the composition of buffer solution? Ammonium chloride, ammonium hydroxide. Then add EBT indicator. The EBT, and when you add the EBT indicator, you will get wine red color. Then titrate it against with EDTA solution. EDTA solution. This wine red color is changes to the, so you have the steel blue color, right? So when you add So when you add the wine EBT indicator, that will be binds to the calcium magnesium. Then after that, when you titrate it against with the base, against with the, so here the EDT indicator. So these EDT indicator, EDTA can be combined with the, so calcium and magnesium ions of the hardness of water. Then the EBT indicator, which is free, right? So that EBT which free of the EBT will gives as what? It is a steel blue color, right? This is a principle about the EDTA method, right? So procedure. So if you take the procedure, first one is what? Standardization of EDTA method. You put out 20 ml of standard hard water into a conical flask, then add 5 ml of buffer solutions, and add 2 to 3 drops of EBT indicator, then titrate it. When you add the EBT indicator, it will get wine red color, then titrate it against with the EBT indicator, right? This procedure is same for the M1 calculation, M2 calculation, M3 calculation, and M4 calculation also, right? So this is a determination of total hardness of water. So in the case of first one, so you are going to find out M1. M1 is equal to what? Weight of calcium carbonate by molecular weight, right? So that we are going to find out weight by molecular weight into 1000 by vein liters. Weight is what? Calcium carbonate weight, we are going to take 1 divided by molecular weight is 100 into 1 by, so here we are going to take 1000 by, so here the V volume is 100, so therefore you will get 0.1, right? That is the M1 calculation, right? So here that is what we are going to take it.